All right, guys. So, we got protons, neutrons, and electrons, and isotopes, ions, and down pat. So, let's talk a little bit about matter. Now, some of this we've already written down. So, matter is the material that makes up the universe. It has a mass and occupies space. We said, takes up a volume. Okay, so that's really all we got for matter. It is made up of atoms. We've talked about the subatomic particles. Protons, neutrons, and electrons make up the atoms. Those are matter, part of matter as well, because they do have a mass, even though it's very, very small, and they occupy space. And even an electron, with its ridiculously light mass, okay, which we even counted as 0 when we were counting protons, neutrons, and electrons, still has a mass and still takes up space. All right, so elements. This is a substance that cannot be divided into a simpler substance by chemical or physical means. Substance that contain only one type of atom. Now, that can be something like chlorine, Cl, okay? All right, iron, Fe, okay? These are both elements, all right, because they're just, you can't subdivide chlorine any further and still have the same properties of chlorine. You can't divide iron, Fe, any further and still have the properties of iron. Now, you could also have O2, okay, or oxygen gas. You can have N2, okay. These are elements as well, okay, because they are both just made up of oxygen and nitrogen, okay. So these can be elements. There'll also be some other stuff that we'll talk about as we go on, okay. But this is just iron. Would just be one atom, okay? Chlorine, just one atom. Oxygen is 2 atoms, but it's still an element because it's only oxygen. All right, molecules. Molecules are bonded of 2 or more atoms of the same or different elements. Put this right here, of the same or different elements, okay? So, going back to our example with the O2, okay? O2 is not only an element or a single thing, okay, single type of atom, it is also a molecule, okay? So oxygen, we got our electrons, all right, we got 2, 4, 6, right, 2, 4, 6, we get a bond here, and we have a molecule, okay? Another molecule could be one that you should know from biology, C6H12O6, or glucose, okay? These are both molecules. Now, glucose is not an element because it's made up of more than one type of element, okay? So it's not a single element, it is many elements, or at least 3. Oxygen, or O2, on the other hand, is made up of one element, so it is still just an element and a molecule. Okay? So we got elements, molecules, and then last but not least, we got compounds. Alright? A compound is a substance that is composed of multiple atoms, multiple type of atoms, I should say. All right, it can be divided down by a chemical process. All right, so sticking with the examples that we got, C6H12O6. So this one is a compound and a molecule. Okay, so that out of elements, compounds, and molecules, they could be one or more. Okay, so this is a compound because we have carbon, hydrogen, and oxygen. Sodium chloride, table salt. We got sodium, we got chloride, so this is a compound. All right. If I just had Na by itself, that would just be an element. Okay. If I have Cl2, which is chlorine gas, all right, we would have an element and a molecule. It can be both. So here's some examples. We got carbon monoxide. This would be a compound. We got carbon and oxygen. All right, carbon dioxide. So we got carbon sitting in the middle. We got two oxygens. So this is a compound. Water as well, and then hydrogen peroxide, which is H2O2. Okay. All right, now there's three forms of matter that we're going to deal with in class. Yes, there's plasma. We're not really going to deal with that. That's mainly in the sun. We're more worried about earthly chemistry at this point. All right, solid. Substance that has a fixed shape and a fixed volume. It is a rigid. All right. So an example, ice cubes. Okay, ice cubes. They're solid. They have a fixed volume. Let's say like this 2 liters. All right, that's not going to change. Okay, and it has a fixed shape, whatever that shape happens to be. Liquids. This is a substance with a definite volume, but it adapts or changes to the shape of its container. Okay? So, example, let's say this is 200 milliliters. Okay? If I got 200 milliliters in this Erlenmeyer flask, and I pour that out into a cup, all right, it's still 200 milliliters. That doesn't change. All right? If I had a big graduated cylinder, okay, 200 ml. So if I have 200 milliliters, okay, it's going to fill it all the way up to here, okay? The volume never changes. Now the shape will, okay? Last but not least, gases. This is a substance that has no shape or a fixed volume. Now why? Valid question. They're going to space out to fill up whatever container it is, okay? So this is a 500 milliliter Erlenmeyer flask. If I were to transfer that gas into a 600 milliliter container, it would fill up the entire container, all over here, all over here, all over here, all over here, blah, 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 whatever. Say the molecules would just be further apart. So let's say they're this far apart in the Erlenmeyer flask. They would be this far apart in this big 600 milliliter container. All right, on the inverse, I have a little 200 milliliter container. Okay? Lid on that since it's a gas. Alright, it's going to fill up the whole thing, so these are little water molecules, would be this far apart. So they space out according to the container they're in. It doesn't matter if it's a large container or small container, they're going to space out as much as possible. So that's why there is no fixed volume. 200, 500, 600. All right. And there is definitely no shape. All right. That's it for this video. Come on back. We'll do some more chemistry.